We're here in the Propulsion Development Lab here at Marshall Space Flight Center, and this is the F1 engine, and it's the engine 6049 is what its designation is. It was originally slated for Apollo 11 flight, however, due to an anomaly on a stage test, it was recycled and planned for a future test that was canceled, so this is how we were able to have it today for our testing. After we disassembled the first engine, we started looking at components that we would like to potentially test. And the first part that we looked at was the gas generator system, which is the part that drives the turbine on the engine and provides the propellants to the injector. We pulled the gas generator, which is located here on the engine, and disassembled it and refurbished it, and it's now located at Test Stand 116 for hot fire testing.
We will be running the F1 gas generator test, which using a Heritage gas generator and running it with liquid oxygen and RP1.
We took this engine apart and we're testing it to develop the performance models and the combustion stability models, as well as the combustion properties, so that we can influence designs in the future for the Space Launch System.
For future work in SLS, one of the biggest things we are looking at is manufacturability. How can we do things easier, cheaper, and faster? And this provides a great opportunity, taking the F1, which is one of the biggest engines America's ever made, and to be able to take that and look at the components and look for opportunities of how can we do rapid prototyping, rapid manufacturing to reinvent these or make them different, make design changes. How do we speed up that whole process when we are going to design an engine and test it?
The data that we're going to collect from our F1 gas generator test program, we'll be able to share with the U.S. aerospace industry to develop engines like this in the future.
The best part of this project for me has been being able to take an engine from start, take it down to its bare bones, clean it up, go in and inspect it as best we could, reassemble it, and then see it get to the point of being hot fired.
So this is the first time that I've been involved in a test like this, and seeing it, knowing all the history and seeing it come apart and being involved from the very beginning and seeing it go back together and out the test stand is something that I'm really excited about. It's the reason I came to work at NASA.